Now, the water is a non-conductive material. Water, as pure water, it doesn't conduct electricity. So you actually have to cheat on water. We have to add something to the water, like a little bit of sulfuric acid, so that it can conduct a charge through it. Now, we don't have time for writing any of this down. I just want you to watch. We can take this spontaneous reaction and turn it around and force it to go in the non-spontaneous direction. We can make hydrogen and oxygen from water. Let's see. For Grace, John, would you hold this for Grace? She's pretty nice, and we'll help her out on this. Over there, behind Mitchell, I have this hydrolysis of water set up. My power supply, back at about 2 o'clock, I kicked this thing on, and in a power supply, they come in different colors and shapes. This one is very, very old, probably from the 1960s. I'm not kidding. Like 50 years old, this thing. It looks like it. Now, I have a dial here. I dialed up the voltage, and what happened is I got an electron, or a wire coming out of each terminal. There's a positive and a negative terminal. With a power supply, the negative terminal, which is the one on the right, that's always the source of the electrons out of the power supply. So the electrons are coming out of here, and they're going in here, and something over here on the right has to reduce. That's the cathode. The electrons are coming out of the power supply, and they're going in there. Something's got to reduce. The electrons then are coming in from the other one. The electrons always go into the positive, out of the negative. All power supplies have a positive and a negative, and the electron flow is always the same. It doesn't ever reverse. So we see that there is a gas that's being collected there. It has gone down and displaced the water to there. The other gas has gone down about twice as far. If you look at the water chemical equation, you can see that if we turn that reaction around and make water break apart into its elements, what gas are we going to make more of? Hydrogen. Is hydrogen reducing or oxidizing to make the hydrogen in water? You got water, hydrogen's got a positive 1. Does it reduce or oxidize when it makes hydrogen? It reduces. It has to reduce. That's why the hydrogen is connected to the negative terminal. The negative terminal is causing reduction. It's putting the electrons in. All right. Now, do you see that 2-to-1 ratio? Does that make sense that we're getting twice as much hydrogen made as oxygen made? Yeah. Oh, man, that's so good. I love when stuff works. It's just so good. Now, the only other thing I want to do with this, we need to go into more of the on-paper detail about this reaction. The bell's about to ring. Let me just show you this, though. We don't have enough fun in this class. This hydrogen, it needs to be collected and burned. Mitch, would you like the match for me? Well, this goes real fast. So I'm going to just collect the hydrogen in here.
Oh, yeah.
How did Mitchell do? Did you get it on 1 try?
2.
2 tries. Still not bad, Mitch. Now, hydrogen is a very low density gas, so it just went up, and I'm trusting that hydrogen is just sitting on top of that. Oh, man. Hydrogen gas. Oh, yes. Okay. You can't go without hearing that. So that's hydrogen gas. Very low molecular weight. Fast burning. We'll talk more about this demonstration tomorrow.